Assalamu alaikum and good evening, children. Today we are going to start grade 10's Newton's laws of motion. So that is unit 4 in your grade 10 science. Okay. So here, before moving into the laws, children, first we should know what is a force. Okay. So what is a force, children? Simply, how do we define a force? Simply we can say it is a pull or push, right? So by using a force, we can pull an object, we can push an object, we can change the shape of the object. Okay. Now see, now think you are having an object here. Okay, if there is an object like this, if you want to pull or push this object, you have to give a force. Without giving a force, if you just stand and if you say the ball to come, will it come? Do you have any magics here? No, right? So you have to give them the force. If you give them the force only, the ball will move. If the ball is at stationary, which means if it is at rest, children, nothing, there is an object. Okay, so if you, now this object is at rest, which means stationary. That means this object is not moving. So if you want to move this object, children, you have to apply a force. Without applying the force, if you just tell the object to move, will it move? Just like in the Harry Potter, when they will do magics and everything. So you can't move like that. Okay, so here you have to apply them the force. Okay, so you have to pull or you have to push. Then only it will start to move. Okay. Always remember, children, if an object is moving, definitely they should have something called unbalanced force. Okay. So first let's see what is that unbalanced force. Okay. Now think, I'm going to take an object. So let's think this object is on a table. Okay. So here, by using a force, okay, I'm going to pull this object. Okay, let's think, I'm going to give that object 3 Newton force. Okay, now at the starting itself, it won't move. Okay, maybe this force is not enough. The reason, children, always there is a force called resistive force. Okay, that resistive force will oppose the motion. It will be in the opposite direction of the force. That means I'm going to apply the force in this direction, means that resistive force will be in the opposite direction. So when I have that resistive force, children, even if I apply the force, this object will not move. Okay, now think, this resistive force is 4 Newton. Okay, now see, I am giving 3 Newton force. Okay, this resistive force means we call it as a friction. You will study about the friction in unit 5. So for now, remember it as resistive force. I am giving 3 Newton in this direction, and there is a resistive force of 4 Newton in the opposite direction. Now, will this object move, children? No. Because why? This force is there. No? This force will not let that object to move. Okay, so that's why this object is not going to move. Okay, now think, after some time, I am going to increase my force up to 4 Newton. Now the resistive force also 4 Newton. No. Now again, if you see, children, this object will not move, because in this direction also, in this direction I am giving 4 Newton. In the opposite direction, I am having the resistive force of 4 Newton. So here, this is just like a tug of war. Okay, you all know tug of war, no? In that, children, there will be 2 groups. No, so think this is the rope. Okay, so here there will be group A and group A. What will they do? Both the groups will put the force. Now group A also will pull by giving some force, and group B also will pull by giving some force. No, okay, in case if both of them give the same amount of force. Now think, this group A is giving 20 Newton and this group B also giving 20 Newton. Now this rope will not move. Why? Because both are giving the same amount of force. No, so the rope will not move. Okay, now so during this time, children, the amount of magnitude of the force are equal. No, so for this only we called as balanced force. Okay, for this, how do we call? We called as balanced force. So in case if there is a balanced force, children, the object will not move. Why? When there is a balanced force, it is like the resultance is 0. Okay, in two directions, no, you are having in two opposite direction. So the resultant will become 0. So that is only we have, for this force we called as balanced force. So that's why I told here, if you take children, we have a resistive force. Resistive force means that is the force which opposes the motion. So we are having 4 Newton and we are pulling the object in the opposite direction by giving 4 Newton. So the direction of the forces are opposite, no? Now, and the magnitude also equal, right? So now these are called as balanced force. So when you have the balanced force, children, the object will not move. Okay. Now let's take another one. Now again, I'm having an object like this. So let's think. I am going to pull this object by using 5 Newton, and think I'm having here the resistive force of 4 Newton. Now children, if you see, I am supplying a large amount of force here, right? So when compared to the resistive force, I have more amount of force, which means I have 1 Newton extra force. No, so therefore, for this only we called as unbalanced force. Okay, unbalanced force. Okay, so balanced force means in this side and the opposite side, the magnitude should be equal. Okay, so in the balanced force, the object will not move. But if you take this, children, here I'm having 4 Newton. Here I am having 5 Newton. So here I'm having that extra 1 Newton. No? So by using that extra 1 Newton, okay, I have 1 Newton more here. By using that, this object will move in this direction. So for that only, children, we called as unbalanced force. So always you have to remember, if you want to move an object, there should be an unbalanced force. If there is no unbalanced force, then the object will not move. Okay. Now, just think, a group of people. Okay, now see, they want to push a bus. Okay, think this is the bus side. I will draw. Okay, now one boy. Okay, one man. Okay, he is going to push the bus. Okay, so you know the bus is very heavy. So one man cannot push the bus. No. Okay, so if he is giving 10 Newton, so likewise, think there are so many people. Now group of people are going to join. So when group of people join these children, there will be a large amount of force. So when there is a large amount of force, that will give rise to an unbalanced force. Okay, that means unbalanced force means to balance that force, we don't have a force in opposite direction. So here if you have 10 Newton and here also if you have 10 Newton in the opposite direction, children, both are equal, no, then that is balanced force. During that time, this bus will not move. Okay, now in case here I'm having 50 Newton and here I'm having 60 Newton, just take it like that value. So when compared to this, children, I have more force here. So this is not balanced. No, this is unbalanced. So only if there is an unbalanced force, the object will move. Okay. Now let's take another situation. Okay, now we are studying about the force. Okay, so I told you a force means simply we say it is a pull or push. By using the force, you can move an object, you can stop the motion of the object. Okay, and you can change the shape of the object. So there are so many applications of the forces. So here I'm explaining y'all, if an object should move, they need an unbalanced force. Okay, now just think, in a textbook, okay, they have given an example, a cart. Okay, a cart is moving. Okay, so this cart is moving. Now in case, children, if I push this cart from behind, okay, now if I give push in a sense, I'm going to give them a force. Okay, so think I'm going to give 40 Newton force. Already this cart is moving. Okay, already this cart is moving with v velocity. Okay, with some velocity it's moving, and also I'm going to add that cart another 40 Newton. Now tell me, children, what would happen? What would happen? Now already this object is, this cart is moving, and again I am giving them 40 Newton force, and that means I'm going to push the cart. So what will happen to the cart, children? Any idea? Yes, very good. The cart will move faster, which means I can say the velocity of the cart will increase. Okay. Now think, I'm going to do like this. Again, now think the cart is moving. Huh? Again, the cart is going to move. Now, I am going to pull the cart in the opposite direction. See, here I am pushing the cart. So that means that is the same motion, in the same direction where the cart is moving. Now what I am going to do, the cart is moving in this direction and I am going to pull the cart. That means in the opposite direction by think like I am giving 40 Newton and I am going to pull it. Now what would happen to the velocity of the cart, children? Will it increase or decrease? Yes, it is slow down, which means we can say the velocity of the cart is decreasing. Here, what has happened, children? Here, when I give the force in this direction, the velocity is increasing. When I give the force in the opposite direction, velocity is decreasing. Therefore, children, we can come to a conclusion like force is having a direction. Okay, so why when I give in one direction it's moving faster, when I give in the opposite direction it's moving slowly. Therefore force means the symbol we give is F, so that is having a direction. And also we are telling a magnitude. No, we are giving a magnitude like 40 Newton, 20 Newton, 30 Newton. Likewise we are giving a magnitude. No, so they have the magnitude. So children, you all know that there are two types of physical quantities, scalar quantities and then the vector quantities. So tell me, where will this force come? That means where will it fall under? Is it scalar quantity or vector quantity? Very good. It is vector quantity. So you all know scalar quantity means, children, they have only the magnitude. Vector quantity means they have the direction and then the magnitude. So force is having both the direction and magnitude. So force is going to come under vector quantity. So these are the stuffs you should know about the force. Now, there was a scientist called Sir Isaac Newton. I hope everyone knows who is that. Okay, see, so he only found the gravity, no? So he was very interested in this force. Okay, so he was studying deeply in the depth. He was studying about the force. Okay, from that only he formulated 3 laws. Okay, he was studying about the force nicely. Okay, he was researching and everything, and he was nicely studying about the force. So from that he formulated 3 laws. So that is only called as Newton's laws of motion. Okay, motion means for a moving object, usually we say Newton's laws of motion. So about that Newton's laws of motion only, children, we are going to study in this chapter. Okay, so let's start up with the first law. Okay, so I'll explain it again by using an example. Okay, and now what I'm going to do is I'm going to have object. So think this object just rest means, children, they don't move, which means their velocity is 0. Okay, they don't move, their velocity is 0, right? Now if I give a force, okay, but which force I have to give? I have to give unbalanced force. Okay, I have to give them unbalanced force. So I explained you what is called as unbalanced force. No, now only when I give the unbalanced force, this object will move. Okay, if there is a balanced force, this object will not move. Okay, so and also think there is another one object. Okay, there is another object. So think this object is moving with a velocity of 3 ms minus 1. For example, I am taking the velocity. Okay, this object is at rest. Okay, that means this is stationary. Here I am saying this object is moving with a velocity of 3 meter per second. Okay, now in case if I give an unbalanced force, okay, now think I am going to give them 4 Newton. Now tell me, children, what will happen with this object? What will happen? Will it be at rest? Will it be stationary again? Or will it move? Yes, very good. It will move. Okay, why is it moving? Because I am giving them the unbalanced force. So because of I am giving an unbalanced force, I am saying this object will move. Okay. Now think, I told you the second situation I told you. This object is moving with a uniform velocity. Uniform velocity means it will keep on moving with the same velocity 3 meter per second. It will keep on moving with the same velocity. Now think, I am going to give them 3 Newton force. What will happen, children? If I give a 3 Newton force in this direction, what will happen? It will move faster. Yes. Now the velocity is 3 meter per second. No. Now the velocity, because of I am giving the another 3 Newton, children, it will move faster. Very good. So the velocity will increase up to, maybe let's take it as 4 meter per second. So what have I done here? Because of giving an unbalanced force, children, I have moved an object. At the same time, I have decreased the velocity of the object. Okay, so this is only Newton's first law. So according to the definition, children, they have given, until an unbalanced force applied on it, body is at rest, remains stationary. Now this is at stationary, no. So if I don't give this 4 Newton, tell me, children, if I don't give this 4 Newton, will this object move? Is it a magic to move? Will it move? No, it won't move. So only when I give the unbalanced force, it is moving. No, when I don't give, it will not move. So that is the thing. Okay. So here they are saying, until an unbalanced force is applied on it, body is at rest, remain stationary. They won't move. Okay. And body is in motion. Okay. Body is in motion. The second one, body is in motion, continue to move at a uniform velocity. Now see, in case if I don't give this 3 Newton, children, they will move with the same velocity of 3 meter per second. Their velocity will not change. So if their velocity doesn't change, children, for that only we called as uniform velocity. So this is only Newton's first law. Okay, so here repeat it again. Until an unbalanced force act on it, body is at rest, will remain stationary, and body is in motion, continue to move in uniform velocity. So until an unbalanced force act, in case if there is unbalanced force, that will change. Okay, children. So did you all understand the Newton's first law? Do you all have any doubts in this, children? Any doubts? Right. If you all have any doubts, you all can send me that in the chat box, children. Right. Okay. Now let's see an example. You all know how to play carom, no, children? So you all know when you all strike the disc, okay? When you strike the carom disc, it will move. Okay. Now let's take in this way. Okay. This is the carom board. Okay. So this, I don't want to draw. Just think this is the carom board. Okay. Right. So here now you will be playing with the disc. Okay, now if you just give a small force, children, what will happen if you give a force? What will happen? What will happen if you give a force, children? What will happen with the disc? That means I'm going to strike the disc. What would happen? Definitely the disc will move here and there. Okay, maybe. Okay, it's going to move here. Okay, now the disc is here. Now what I'm going to do is I am going to add some powder to this carom. Okay, for that board, I'm going to put some powder. So when I put powder, children, what would happen? So this is without the powder. Now tell me, when I put the powder, what will happen? It will move faster. Why is it moving faster? So here the children, if you see, before you apply the powder, there was a resistive force. Okay, resistive force means what will it do? I told you, if the object wanted to move in this direction, there will be a resistive force in the opposite direction. So they will not let that object to move. So that's why it will move only for a smaller distance. Okay. when you apply the powder, children, this surface is there, no, it will become smooth. That surface will become smooth. So when the surface becomes smooth, children, this resistive force will not be there. So or else you can say the resistive force will decrease. So when the resistive force will decrease, it will move to a longer distance. So that is the reason. Okay, so that's why usually we apply a powder to the carom board. Yeah, so you can say it is friction. So about the friction, you will study in unit 5. So now we are studying unit 4. No? So that's why I'm not using that word here. Okay, so resistive force means, children, for that we say friction. So it will oppose the motion of the object. Okay, now let's take another example. Okay, so now think a man, okay, a man or a passenger is standing on the bus without holding. Okay, now think the bus is moving. The bus is moving. So think the bus is moving with 30 meter per second. So this passenger also will have the same velocity. Okay, y'all should know this. Okay, now this passenger is not holding. Okay, usually it's like that, children. When you travel in the vehicle, you will have the same speed of the vehicle. You will think like you're in the rest, but you are having the same velocity of the vehicle. Now I'm saying this bus is moving with 30 meter per second. Okay, so the passenger also will have the velocity of 30 meter per second. Now think suddenly, okay, suddenly this bus, okay, that is going to apply a brake. Okay, think the bus is going to apply a brake. So when the bus apply a brake, what will happen? The velocity of the bus will become 0, right? Yes, yeah, he will fall. I'll come to that. Now what will happen when the bus apply the brake? The velocity of the bus from 0, it will come to from 30, it will decrease to 0. Okay, now if you take the leg, that means if you take the feet of the passenger, children, it is in contact with the footboard of the bus. No, okay, now when the bus comes to rest, so the feet also will be at the rest because it is in the contact. But if you take the upper part of the passenger, that means above that feet, if you take, it is not in contact. No, only the feet is in contact. So when the bus comes to rest, children, the feet also will come to rest. The velocity will become 0. But the upper part, it is not in contact with the bus. No, so already this one was traveling with 30 meter per second. So suddenly when the driver apply the brake, children, this will be in the rest and the body will move. That's why we fall in the forward direction. That's what happened there. Okay, so when the bus suddenly apply the brake, children, the feet will be in contact with the flow of the bud. So that's why the feet the feet velocity will be 0. But if you take the upper part of the body, it is still moving. It won't come suddenly to the rest. It won't suddenly come to the rest. Little by little on, it will come to the rest. So it will take time. So that's why they will fall forward direction. So this is the reason. Did you understand this, children? Did you understand this concept? Any doubt? Any doubts? Right. So let's see, take another situation. Now think this passenger, he's sitting on the seat. Okay, like this. Okay, or else let's take he's standing. Okay, let's take it as he's sitting. Okay. Now this is the passenger. So this is how I'm going to draw. Right. Now think this bus is at rest. Okay, now the velocity is 0. So the passenger's velocity also 0. No, bus is not moving. So the passenger also won't move. I'm saying he is sitting inside the bus. Okay, so always he will have the velocity of the bus only. Okay, now think suddenly without his knowledge, okay, without this passenger's knowledge, this bus is going to move. Okay, without his okay, think the passenger is sleeping, he was not here. So suddenly the bus is going to start to move. So that means suddenly, so the velocity, what will happen? Let's take the now velocity is 20 meter per second. Okay, now he is sitting. No, so the lower part of the body, okay, he's sitting, right? So the lower part of the body will get that velocity 20 meter per second. But if you take the upper part, children, it is still at rest. Little by little only it will take the velocity of the bus. So still it is rest, no? So suddenly when the bus start to move, this is at the rest, no? So suddenly when the bus move to 20, it will still be rest. That's why this passengers will fall backwards. Okay, he will fall backwards. Why? His legs are in forward because a bus is moving, because his lower part is having a velocity of the bus, but the upper part is not having the velocity. So upper part will be still in the zero velocity. Lower part will have the velocity of 20. So that's why he will fall backward. So that is the reason, children. Okay, when the passenger is standing on the bus, so I told you when the bus apply a sudden brake, a passenger will move forward. That means he will fall forward, and in suddenly, without the knowledge of the passenger, if the bus starts to move, then the passenger will fall backward. So this is what happens here. Did you understand, children? So this is the concept. So this is based on Newton's first law. So that means if there is an unbalanced force only, if the object is at rest, it will start to move. Okay. Now I'm saying here the object is at rest. No, this person is rest. Okay. The upper part of the body is rest. So suddenly when they apply the force, what's happening? He is falling backwards. So that is according to Newton's first law. At the same time, if the object is moving with a velocity, it will continue to move with the same velocity, which means the uniform velocity. So in case if you apply a force on the children, it will move faster. Then only the velocity will change, only when there is a unbalanced force. Okay. So both are going to come under Newton's first law. Okay, children. Did you understand? You'll have any doubts? Any doubts, children? Okay, so then let's go to the Newton's second law. Okay, the first law, I'll repeat the first law again. Until an unbalanced force is applied on it, bodies at rest remain stationary, and bodies in motion continue to move to the same velocity. That means uniform velocity. So then let's go to the Newton's second law. So we are going to study this Newton's second law based on the acceleration. Okay, you all know what is acceleration? No? Can someone tell me? Tell me, what do you all mean by acceleration? I have studied this already in unit 2. Tell me, what is an acceleration, children? What do you all mean by acceleration? Yes, rate of change of velocity. That means if there is an increase in velocity, for that only we called as acceleration. No, when there is a change in the velocity, a rate of change, or you can say increase in velocity, only called as acceleration. Okay. Now this acceleration is directly proportional to unbalanced force, not the normal force. It is unbalanced force. Okay, directly proportional to unbalanced force. That means, children, when the force increase, acceleration also will increase. That is only meant by directly proportional. Okay, when the unbalanced force increase, acceleration also will increase. So I'll explain it by using an example. Okay, now think there is a trolley. Okay, so here there is a trolley and there is a rubber band. Okay, I'm going to tie a rubber band in the one end of the trolley, and by giving a F force, okay, by giving a force, I am going to pull an end of the rubber band until the other end of the trolley. I'm going to pull it. Rubber band means you can pull, no, children. So I'm going to pull that until the other end. And I am going to release my hand now. I'm going to pull it up to here and I am going to release my hand. Now tell me what would happen to this trolley. What will happen, children? If I pull the rubber band and if I release my hand, what will happen? Yes, very good. This trolley is at rest. The velocity is 0. Okay. Now I am pulling the rubber band and I am releasing. What would happen? this trolley will move. Maybe they will get a velocity of, let's take it as 2 meters per second. Okay, it will move. Okay. Now think what I am going to do is, again the same trolley. Okay. Again the trolley at rest. Okay. Now I am going to tie 2 rubber bands. Here 1 rubber band. No. Now I am going to tie 2 rubber bands. Okay. Here 1. Here 1. Now I am going to pull both the rubber bands until the other end of the trolley. Like this I am going to pull. Okay. Now here if I give F. Okay. I have given F force. Here F. Here F. And altogether now I am having 2F. Okay. Now I am going to release the rubber band. Now what will happen, children? What will happen now? Yes, when compared to the previous situation, now the trolley will move faster. That means I can say, children, the velocity will increase. Here I gave F force. Here I gave double of that. So 2F force. So children, when I give more force, I can increase the velocity, right? So that means, children, here I'm having an acceleration. So actually, when I increase the unbalanced force, acceleration has increased. Now just think, you all know that the paper and rubber game. So what will you all do for your friends? Or you all will play that, no? You all will take the rubber band and you will take a paper and you will hit them with the paper. Okay. In case, think you are going to use 1 rubber band, then it will pain only, but the pain, that is only less pain. Okay. When you take 2 rubber bands, it will pain more. Okay. Because why? The force is high. So definitely the acceleration is high. So the paper will move faster. So when the paper move faster, it will pain for them a lot. It will pain a lot. Okay. So if you all are very angry with someone, if you all can take 2-3 rubber bands and take the papers together and throw it, then what will happen? It will pain for them more. But don't go to try. It really hurts. It really hurts. Okay. So don't go to try. Yeah, after that your parents will come and question me. Right. So that is what we have. So when you take 1 rubber band and when you throw the paper, children, it will, like, their velocity is low there. Okay, they are having a small amount of velocity, less amount of velocity. When you have 2 rubber bands, your force is high, so the velocity will increase. So it will hurt a lot when compared to the previous one. Okay, so that's what I told you. If you are very angry with someone, you can do that and see. Try and see if you all want. Okay, right. So that is based on the force. So as I told you all, acceleration is directly proportional to unbalanced force. So when the unbalanced force increase, acceleration also will increase. Okay. And then the second factor, children, acceleration is inversely proportional to its mass. That means when the mass increase, acceleration is going to decrease. Okay. When the mass increase, acceleration is going to decrease. Okay. Now I'll take the same example, which means I'll take the same trolley and explain to you all. Okay. So here what I'm going to do, I'm going to take the same trolley, just like the previous one, children. I am going to tie a rubber band. Now think, inside this trolley, I have a mass, an object. So the mass of that object is M, for example. Okay. Now I'm going to pull this rubber band, which means by giving F force, and I am going to release my hand. Now what will happen, children? What will happen? What would happen? Yes, the trolley will move. Okay, so in this direction, the trolley will move. Let's take the trolley is going to move with 2 meters per second. Okay, now children, what I am going to do is, I am going to take the same trolley and I am going to tie the rubber band and I am going to pull it. But now the mass of the object I'm going to increase by another M. So which means altogether, now I had the mass of 2M. Now what would happen, children? Tell me, will this move? Yes, it will move. Okay, but when compared to the previous one, children, now it will move very slowly. Now just think, will you practically, now you are going to school. Okay. If you go to school, what will happen? If you go to school, they will teach you. I'm not asking about that. Now you all will take the books and go on. So if you take less amount of books, Okay, you can walk faster. But just think, if you have so many books to carry and go, children, you will walk very slowly because your bag is heavy, no? That means your mass is high there. So when the mass is high, your speed is decreasing. Now you all can take this example, usually for Muslims, okay? During Ramazan, okay, now the Ramazan is nearby, so it is close by, children. So if you take during Ramazan, before breakfasting, you all will quickly come and sit and you will eat, okay, you will break fast, right? They will eat, so around when the Maghrib Azan says, okay, so that means fathers, if you all want to say, when the prayers goes, they will start to eat, no, so they will break fast. During that time, children, you are very hungry, you all will be very hungry, so you will eat a lot. Yes, you will eat a lot, but after eating, you can't even get up from that place. Why? Because you have so much amount of food in your body. Okay, so that is the reason. Your stomach, you have so much amount of food. So what's happened there? So actually, that is, I'm saying it for funny. Actually, that is scientific reason. I can't tell, but just for fun, I told you all. Okay, so here, before breaking fast, empty stomach, no. So no mass. Okay, after eating, you have so much amount of food, so the mass has increased, so it will be very hard, even you can't even get up from that place. Okay, that much you will eat, that much amount of food. Okay, so something like that. Okay, so here also, as I told you all, when the mass increase, acceleration will decrease. Okay, so inversely proportional. So this is only, children, Newton's second law. Acceleration is directly proportional to unbalanced force and it is inversely proportional to its mass. Okay, so based on these two, children, there is a formula. We have constructed a formula as F is equal ma. Okay, F is unbalanced force, m is mass, and a is acceleration. Did you understand, children? Any doubts? So this is the Newton's second law. Okay, you should remember that. So by using the trolley, I explained to you all. So this is the activity they have given to you. Any doubts, children? So by using this formula, children, you should be able to do questions. So let's see an example. Now think, a mass of an object is 5 kilogram, and they are saying the acceleration of that object, acceleration means A, is equals to 2 ms minus 2. Okay, so ms minus 2 is the unit of the acceleration. Now the question, children, what is the force applied on that object? So what is the formula? F is equal ma. So m is 5 kilogram, a is 2 ms minus 2. If you multiply, you will be getting 10 Newton. The unit of the force, children, that is 10 Newton. Okay, so likewise, if they ask you like these type of questions, by substituting in this formula, you should be able to do that. Okay, so let's see some questions. I'll give you some question, quickly do that. In the first question, I want you all to find the mass. So they have given you the force, they have given you the acceleration. Find the mass. Quickly do this, children. It's very simple question. Quickly do this. What is the answer, children? So you can substitute directly in the formula. The formula is F is equal ma. So F is 10 Newton. M we don't know, that is the question. And A is 2 ms minus 2. Okay, it's ms minus 2. So M is equal, if you take the 2 that side, it will go as a division. So 10 divided by 2, children, it is 5 kilogram. So this is how you have to find. Okay, just simple formula. Newton's second law. Okay, so we are done with Newton's first law. We are done with Newton's second law. Now, children, let's go to Newton's third law. Newton's third law means, children, for every action, there is an equal and opposite reaction. Okay, for every action, there is an equal and opposite reaction. Now, let's take it like this. Okay, think you are going to slap your friend. If you slap your friend, children, will he laugh at you? No. What will he do? He will also slap back? No. That is only Newton's third law. For every action, you are slapping your friend. No, that is the action. He will slap you back. That is the reaction. With the same force, he will slap. If he slap with the same force, only it is Newton's third law. If he slap with the double force, that is not Newton's third law. Then you have to go to the hospital, right? So Newton's third law means, children, for every action, there is an equal and opposite reaction. So that is a simple law. Okay. Now, think you are going to give 5 Newton. Okay. So that means you are going to slap by using 5 Newton. So your friend also will slap you by giving 5 Newton. Okay. Slap, not anything else. They are giving slap. Okay. So this is, you are giving, no, first, who is the first person? You only gave. So this is the action. Okay. And he is giving, that is reaction. And see the direction of the forces. Can you see? So both are in the opposite direction. So that is what told. For every action, there is an equal and opposite reaction. Now, based on this Newton's third law only, children, if you take the rockets, those stars will work according to that Newton's third law. Okay, now just take a balloon, will you? Okay, take a balloon. Okay, balloon means you all know it is filled with air molecules. Okay, now, so think you have, now you are going to release the air. Okay, now what will happen? This balloon is there. No? This balloon will push the air molecules out. Okay, so you are releasing the balloon. So this air, the balloon, the walls of the balloons are there. No? It will push the air molecules down. That is action. So if they push the air molecules down, will the air molecules just wait? They will get angry, no? So they will push, air molecules will push the balloon wall up. So that's why, that is reaction. So that's why, children, balloons moves up. You all know, usually if you release a balloon, it will move up. What is the reason? This is the reason, Newton's third law. So first the balloon walls will push the air molecules out. Okay, it will push it out. Okay, that means it will move, push outward. Okay, down, right? That is action. Now the air molecules will get angry, right? So then they will push the balloon up. So that's why the balloon will move up. So that is Newton's third law. Okay, so that's all you have in that, children. So these are the 3 laws of Newton. Okay, so the third law is, for every action, there is an equal and opposite reaction. Did you all understand, children? Any doubts in that? Do you have any doubts? Okay. So then I'll just give a summary of the first 3 laws, children. The first law, as I told you, until an unbalanced force act on it, bodies at rest remain stationary, and bodies in motion, what will it do? It will continue to move at a uniform velocity. Okay, now think, if the body is at rest, it will stay at rest itself. It will remain in stationary. If the body is moving, it will move with a uniform velocity. Until when? Until an unbalanced force applied on it. In case if you apply a force, this can change. Okay, this can change. So that is Newton's first law. In Newton's second law, I told, acceleration is directly proportional to unbalanced force, and also it is inversely proportional to its mass. So from that only we got the formula as F is equal ma. So this is Newton's second law. Okay, and then the third law, children, for every action there is an equal and opposite reaction. That means, now think, there is an object on a table. Okay, now this object is going to give 3 Newton force in downward direction to the table. Then the table will get angry, no, just like us. Then the table also will give the opposite direction. It will give a force in the opposite direction. That also will be the same in magnitude. So for that only we say perpendicular reaction force. Okay, for that reaction only we say perpendicular reaction force, and for this only we called as weight. That's why the book will be stationary on the table. Okay. Okay, they are saying me to repeat the first law again, children. The first law is until an unbalanced force. Okay, unbalanced force means, children, now see, if I'm having a 3 Newton force in this direction, in the opposite direction also if I have 3 Newton, for that I called as balanced force because both are equal in magnitude. So I call this as a balanced force. In case only in this direction if I have a force, so to balance this, if I don't have a force in this direction, then for that only we called as unbalanced force. So only when there is an unbalanced force, the object will move. Okay, object will move, and if you want to stop the motion of the object also, you need the unbalanced force. Okay, without the unbalanced force, you can't move an object, or you can't change the velocity of the object, or you can't stop the motion of the object. For the everything, you need the unbalanced force. So that is only the Newton's first law. Okay. So then, do you all have any doubts in that, children? In these 3 laws, do you all have any doubts? No doubts? Okay. So then, let's go to the next part. Next part, children, the momentum. Okay, so the next part, that is the final part we have. Okay, we have the mass and weight also. So let's start up with the momentum. Okay, momentum means, children, it is going to describe us how difficult, think object is in a motion. Okay, think this object is moving. Okay, momentum tell us how difficult it is to stop the motion of the object when it's moving. So that is only momentum. Momentum will define. It will describe how difficult is to stop the motion of an object. Okay. Now think, children, a friend of yours throwing a pen towards you. Okay. A friend of yours throwing a pen towards you. So easily you will catch the pen. No, it is not that hard. You can easily stop the motion of the object. Okay. Now I'll ask you another question. In case if there is a bullet, okay, bullet, you all know what is a bullet, no? So if a friend throw a pen to you, if the friend throw a pen towards you, it is easy for you to stop the motion of the pen. Okay, it is not that hard. Okay, but in case if there is a bullet, okay, think a bullet is coming towards you. Is it hard for you? Is it easy for you to stop the motion of the object? Children, say yes or no. Is it easy? See, now don't tell like heroes and heroines, I can stop the bullet. You can't stop the bullet, children. If the bullet is coming towards you, it is difficult to stop the motion of the bullet. Why? So here that comes like this. This moment depends on 2 factors. One is mass and other one is velocity. Okay. Moment depends on 2 factors. First factor is mass and the second factor is velocity. Okay. If the mass increase also, the momentum will increase. For momentum, the symbol we give is P. Okay. When the mass increase, momentum also will increase. Okay. When the velocity increase also, children, momentum will increase. Now, if you take the bullet, children, bullet is not heavy, no. Their mass is very low. They are not that heavy. Okay, their mass is low. Okay, they are having a very small mass. Okay, but their velocity is high, right? Their velocity is high. So because of that, bullet is coming in the high speed only, children. You won't be able to stop the motion of the bullet. Now see, the bullet is coming like this. Is it possible for you to stop? Bullet is not heavy, but they have a high velocity. So because of that high velocity only, children, it is difficult for you to stop the motion of that bullet. Okay. Take another example. Take the putt shot. Do you know what is a putt shot? In the sports meets and all, they will use to play. Okay. Now think a putt. Okay. So if it's moving, is it easy for you to stop the motion of that object, children? Tell me. Is it possible for you to stop first of all? No. You can't stop that. Why? If you take that, children, their velocity is low. Okay, they don't have that much velocity, but their mass is very high. They have a larger mass. So because of they are having a larger mass, children, it is difficult for you to stop that object from the motion. So that is only the momentum, children. So momentum explain us how difficulty is to stop the motion of the object. Now, if the object is moving, momentum describe us how much it is difficult to stop the motion of the object. Okay, so that momentum depends on two factors. One is mass, another one is velocity. So when the mass increase, also the momentum will increase. When the velocity increase, also the momentum will increase. Now just take a motorbike, will you? A person is riding the motorbike. So here if you see, motorbike is anyway, it is heavy. So the mass is anyway high. And their speed, velocity, that is also high. So mass also high, velocity also high. Therefore, they will have a larger momentum. So it is very difficult to stop the motion of the bike. So that's why if there is a stealer children, the police can't catch them. So what is the reason? If they are going in a bike, I mean. Okay, so what's the reason? That their momentum is very high. Okay, so it's very difficult to stop that motion. Okay, motion means moving. For that moving only we say motion. Okay, so moving, some objects are moving, can be a vibration or just moving. For that only we say motion. Okay, so from this, children, we have there is a formula for momentum. Momentum is equals to mass multiplied by velocity. So mass is m, velocity is v. So this is the formula. Momentum is equals to mass multiplied by velocity. So the unit of the mass, children, kilogram. The unit of the velocity is ms minus 1. Therefore, the unit of the momentum is kilogram ms minus 1. Is it clear? Did you all understand, children? Any doubts? Any doubts? Right. So, yeah. Okay, so that's all we have up to that part. Okay, so that is the unit. And also, if you take, children, you all know, tell me, velocity is vector quantity or scalar quantity? Velocity is vector quantity or scalar quantity? It is vector, no? Why? They have direction and they have a magnitude. So this is going to come under vector quantity. Momentum also, children, vector quantity. Okay. Mass is scalar quantity. They don't have a direction. They have only the magnitude. So mass is going to come under scalar quantity. Momentum is vector quantity. Okay. So which means they have both direction and then they have direction and the magnitude. So it is going to come under vector. Okay. So that's all we have up to that part, children. And then we have to go to mass and weight.